You might hear some background noise. It's a windy and stormy day in the Mojave. Today's video is on a fairly rare carburetor. You may never see one of these unless you're like me and like to frequent junkyards. But Ford made these back in the late 70s. I think 77 was the first year for this. And they made them through the early 80s. And then they kind of went away when fuel injection came along in the mid 80s. But they're kind of a novelty, and they do work well when they're set up correctly and when the issues have been addressed with it. It's a Motorcraft VV carburetor, variable Venturi. And not much is similar with this to a normal carburetor. I guess there's a few things. So if you look at the bottom side, you can see it's got butterflies like a normal carburetor. And once we get it apart, you'll see that it has a float bowl and a needle and seat like a normal carburetor. And you can see on the side there it's got a choke cap like a normal carburetor. But this carburetor doesn't have a choke. It's got these funky black plastic slides on top. And back in the day, they weren't well received. In fact, even at the dealership, most guys would just take this off and put a Motorcraft 2100 two-barrel in its place. And I'm not going to knock that decision, because these carburetors do have some issues that will crop up with time, and there really isn't a fix for that, and I'll go into that a little bit later. In the aftermarket, you would probably see this carburetor replaced with something like this one, which this of course is a Holley 21 or 2300 two-barrel, and that's okay. But I always thought they were kind of a novelty, and that's why I've hung on to this. I've had this carburetor for about 30 years. And the one thing that they do extremely well is, if they're set up properly, fuel economy. You can get extremely good fuel economy out of a VV. In fact, the best miles per gallon that I've ever gotten out of a pickup of any sort was with this carburetor on a 1981 F-150. I managed to get 19 miles per gallon highway with this carburetor. So they can get extraordinarily good fuel economy. And they're variable Venturi. Well, what do we mean by variable Venturi? So if you remember part 3 of my Summit Carb video, you can check that out. I talked about all of the different circuits in a typical carburetor. So I was talking about 4 barrels in that particular video. This is a 2-barrel. In a 4-barrel, I was talking about the 5 different fuel circuits. This one would have, if it were a 2-barrel 2100 Motorcraft, it would have 4. So we would have an idle circuit, we would have a transition slot or an intermediate circuit, we would have the main jet, we would have the main jet on either a power valve, or in the case of something with metering rods, we would have enrichment fuel on the metering rod. And then at wide open throttle, well, that's, I guess we discovered our 4 circuits. So idle, transition slot, main jet, and then enrichment, whether it be a power valve or a metering rod. We need enrichment at wide open throttle. So 4 circuits. And for years, engineers have known that with something like this variable Venturi, they wouldn't need all that. So this carburetor, you'll notice, has no idle mixture screws at all. Nothing. The only enrichment that happens with this carburetor is off of this bimetal cap here, and when it's cold, it will lift this plunger, and that will enrich the circuit. It's almost like a power valve circuit inside of the carburetor, but it's only for cold start. And then once that heats up and drops off, all of the enrichment is handled by these slides. So it's pretty cool the way that they work. And variable Venturi carburetors are not a new thing. There's quite a few aftermarket Venturi carbs. Predator is one example. I think Fish might be another. As far as OE equipment, I only know of two. There may be more. Motorcycles, of course, there's quite a few examples, but in the automotive realm, we only have this and the Rochester Varijet. And unfortunately, both of those carburetors had issues, but these could be fixed pretty easily. And as far as I know, I did a quick internet search, the parts to fix this are still out there. So let me go over that real quick and I'll show you what happens to these. So the enrichment is happening on this carburetor with these slides, which are attached to metering rods. And you can see those rods. These are metering rods right here, and I'm going to get this apart in a second so you can see them a little better. But on the back of the carburetor we have this. This is a diaphragm inside of this cover. So let me zip this cover off real quick so we can see what's going on. Now this carburetor hasn't been in a part for many years, so I'm going to go a little slow here. So we see a spring, we see a diaphragm. You'll notice this diaphragm is orange. We'll talk about that in just a second. And you'll see that it hooks onto the slide assembly. So as this slide assembly moves back and forth by this diaphragm action, it controls these metering rods. Now, on the front of this carburetor, we have these ports. Now, these are normally covered by little tiny cork plugs. So I rebuilt this about 30 years ago, and I didn't put these back in. I just left them out because I knew I'd be tuning on it. So I made up these little plastic things to stick in there. If you pull these out with it running, it will suck vacuum into these holes and the car will stall. So you can't leave those unplugged. Inside of these two holes are jets that can be moved in and out. And what's really neat about that is you're not just adjusting idle, you're adjusting the entire fuel curve. This is the same thing as shimming the needles on a Mikuni motorcycle carburetor. By moving these in and out, you're just changing the relationship between these tapered metering rods and the jet. Let me see if I can get one of these out real quick. I'm going to pull the metering rods out of the way. This is an extremely fine thread to give you a good range of adjustment. A good starting place is to bottom them and turn them two turns out from bottomed. And it's going to stubbornly refuse to come out. Oh well, we'll get to that in a second. So this diaphragm, the way that this works is down inside this carburetor, there's ports. And those ports, as the airflow moves through the carburetor, exert vacuum on the back side of this diaphragm cover through this port right here. It comes in through, and the vacuum is exerted on the back side of the diaphragm, so it pulls it that way, this way. That's what opens up the slides and enriches the fuel. This is the main thing that fails in these carburetors. The original VV had a black diaphragm in it, and aromatic fuels would attack that and cause it to swell up and stop working. So this is an updated version. It's orange. These are the better diaphragms. This one's actually still in good shape. I think I can run this carburetor just the way that it is. So we've done quite a few of these over the years as Ford techs. I did probably dozens of them back in the late 70s or the early 80s when I was a Ford tech at a dealer. And this was a common replacement part. We used to put these things in. We'd also make a modification to the cover. We would drill this hole. And the reason you would drill this hole is to let fuel vapor out so it wouldn't attack that. So that was the single biggest problem that we had with these. These diaphragms would swell up and the thing would stop working. Stop enriching, or would be rich all the time and run very badly. The second thing that happened to these carburetors is if you over tightened the air cleaner wing nut, it would pull up on this right here and it would warp the case or the housing. If you warp the housing in one of these slides don't move freely anymore, and you'll get the same thing. It'll be either rich or lean depending on where these slides stick. So that's something else you're going to be aware of. Don't over tighten the wing nut, air cleaner wing nut on these and warp this casting. So that's the two biggest things that happen to these, and by far this was more common. So these are still available. You can get them. I wouldn't put a black one in one of these carburetors. I would put an orange one in. But let me go ahead and zip it apart real quick so you can see the inside of it. Explains it. We'll deal with that later. There we go. Okay. Pin is pretty rusty. All right. So we have a typical float. And that would pop out. There's going to be a needle and seat under here. So this is our enrichment plunger. This would normally plug a port, and when it enriches, it lifts up to allow fuel to flow through that port. This is going to be our accelerator pump. So that it does have a typical accelerator pump, just like a normal carburetor, but they do not squirt as much fuel as a typical carburetor. That's one of the reasons they get better fuel economy. I did manage to not tear this gasket. I'm happy. So I can put this back together. And it is runnable the way that it is. There is a fuel filter in here. And obviously it needed to be cleaned up on the inside. So these things do have an idle compensator, a hot idle compensator right here. So a hot idle compensator on a hot day, this bimetal strip will lift up and allow vacuum or allow air in to lean out the circuit just a little bit because it'll percolate on a hot day. And it's just a fuel trim for a hot day. So, okay, let me see if I can get one of these jets out. Deploy some hemostats. There we go. So this is our jet. There's two of these, and these can be moved in and out. There's obviously a hole in the middle of it. It's kind of hard to see, but there you go. And these tapered rods just move in and out of that jet. So you can move these in and out and adjust fuel curve from idle all the way to wide open throttle. That's what's really cool about these. Depending on what these are bolted to, these metering rods, the taper will change. So if it's a small engine, they put these on, I believe they put these on 2.8 liters, as in Ranger pickups. And put them on small V8s is probably the most likely application for it, would be something like a 302. But they did put them on bigger engines, like 400 modifieds, or 351Ms or 400s. So this would have a different jet, because the fuel curve obviously would be different. So depending on what it's on, it may have a different tapered rod. This one supposedly come off of a 351M or a 400, but I've run it on a variety of different engines, and it works just fine. So pretty neat. So moving part wise, there's not much to it. I mean, in some ways they're more simple than a typical carburetor, because there's a lot of circuits that just aren't there. So you don't have to have an idle circuit, you don't have to have a transition slot in the base of the carburetor. There's just one port, and you can see those ports right there. Right there. And that's what generates a vacuum signal to pull on the diaphragm to move the slides to adjust the fuel. So pretty interesting carburetor. And they do run very well when they're set up correctly, as long as it has a good diaphragm on it. And there are no other problems with it, they'll work just fine. And I like them for fuel economy, I really do. Other than that, I don't really know of any reason somebody would choose to run one of these over a standard 2-barrel. Other than the novelty of it, or if somebody was trying to chase fuel economy with a vehicle. They don't flow a lot of air, they don't make a lot of horsepower. Not even sure what the CFM of this one is, but it's not going to be very much. So this is the enrichment, and this actually works backwards compared to a regular Ford 2-barrel. And these are obsolete. You cannot get these anymore for VVs. But if you're careful and you can get this open, what you can do is take a 2-barrel choke cap and you can pop the spring off and you can flip the spring over. So it's probably going to have to be like this. So what you want is for it to work backward. As the bimetal heats up, instead of turning this way, you want it to turn this way. So you can just flip it over. So you can, if you can find a 2-barrel choke cap and pop the bimetal strip out and flip it over and put it back in, this will work for a VV. So put that back on and it would work just fine. So it may be obsolete, but there is a workaround. This little device is a cranking enrichment solenoid. The early 2700 VV had this, and all it did was supply a little bit extra fuel when cranking so the car would start on a cold winter day. I never wired this in on all the vehicles that I ran. I just gave the accelerator pedal a couple more pumps than usual on a cold day and it would start right up. Ford eventually got rid of this and they just added a little bit of extra fuel through the plunger, and that took care of that problem. There was a feedback version of the VV carburetor, and you'll know it when you see it because it'll have a solenoid screwed right into the side of the carburetor. That was known as the Motorcraft 7200 VV, and that one required a whole host of other electronics: throttle position sensor, coolant temperature sensor, oxygen sensor, computer, wiring harness. So I never really messed with those, but the earlier one, if you're putting together a project, is probably the one you want, the 2700 VV, which is this one. So that's basically it. A lot of guys hated these things, just mainly because they didn't know them. Once you know what the problems are, pretty easy fix. These things have been around for a long, long time, and there are some books out there for them. I've had this for over 30 years, but they're kind of a neat little carburetor, and like I say, they're very good for fuel economy. I may run this again someday. It's one of the reasons I'm taking it apart. I'm going to clean it up, maybe drop the castings in the bead blast cabinet and clean them up, and maybe throw it on something someday. There you have it. Thanks for watching.